Welcome to an extraordinary journey into the world of physics, where we explore the groundbreaking work of Sir Isaac Newton, one of the most influential scientists in history. Did you know that Newton's three laws of motion not only explain how planets move, but also influence everything from the design of your bicycle to the launch of a spacecraft? Today, we delve into a comprehensive guide to Newton's laws of motion, unraveling their mysteries and exploring their profound impact on various scientific and technological fields. Sir Isaac Newton, an English mathematician, physicist, astronomer, and philosopher, lived from 1642 to 1727. His work in physics, particularly the formulation of the three laws of motion, marked a turning point in our understanding of the universe. Newton's laws have become the cornerstone of classical mechanics, influencing countless scientific and technological advancements. Newton's laws of motion are pivotal in our understanding of mechanics. They revolutionize the way scientists and engineers approach problems related to motion and forces. These laws are not just theoretical constructs. They have practical applications in various fields, including engineering, aerospace, and even sports. By understanding these laws, we can predict the behavior of objects under different conditions, design safer vehicles, and even explore the cosmos. Let's start with Newton's first law of motion, often referred to as the law of inertia. This law states that an object at rest will stay at rest, and an object in motion will stay in motion with a constant velocity, unless acted upon by a net external force. Inertia is the resistance of an object to a change in its state of motion, and mass is a measure of an object's inertia. The more massive an object, the harder it is to change its state of motion. An object is in equilibrium when the net force acting on it is zero, meaning the object is either at rest or moving with a constant velocity. Real-life examples include a car stopping suddenly, where passengers continue to move forward due to inertia, and an object at rest remaining at rest unless acted upon, such as a book on a table. Next, we move on to Newton's second law of motion, which describes the relationship between force, mass, and acceleration. This law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass, expressed as the equation F等于 ma. F equals ma. This law explains how acceleration is affected by changes in mass and force. For example, pushing a cart with more force will make it accelerate faster, and it's easier to push an empty shopping cart than a full one because the mass of the full cart is greater, requiring more force to achieve the same acceleration. Engineers use this law to calculate forces in different scenarios, and it's crucial in the design of safe and efficient vehicles, buildings, and machinery. Now, let's talk about Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. This means that whenever one object exerts a force on a second object, the second object exerts a force of equal magnitude and opposite direction on the first object. Action and reaction forces are equal in magnitude, but opposite in direction, acting on different objects. This law applies not just to physical pushes or pulls, but also to situations involving gravity, electricity, and magnetism. Real-life examples include rockets launching, where the downward force on the gases is equal to the upward force on the rocket, and walking, where your foot pushes backward against the ground and the ground pushes forward with an equal force. Understanding Newton's laws of motion allows us to solve a wide range of physics problems. The key steps include identifying forces, drawing free body diagrams, and applying the laws to find unknowns. Common misconceptions include thinking that a force is required to maintain motion, contrary to the first law, or that heavier objects fall faster, which does not consider air resistance. It's important to clarify that forces act in pairs, according to the third law, and that acceleration depends on both force and mass, as per the second law. While Newton's laws are typically applied in inertial frames, where the observer is not accelerating, in non-inertial frames, additional forces, pseudo-forces, must be considered. At very small scales, quantum mechanics, or very high speeds, relativity, Newton's laws are insufficient and are replaced by quantum mechanics and relativity theories. In summary, Newton's first law, inertia, states that objects remain in their state of motion unless acted upon by a net external force. Newton's second law, F equals ma, describes the relationship between force, mass, and acceleration. And Newton's third law, action and reaction, states that for every action, there is an equal and opposite reaction. These laws form the basis of classical mechanics, are essential for understanding everyday phenomena, and have practical applications driving technological advancements. We encourage you to observe these laws in action in your daily life, such as while riding a bike, playing sports, or watching a rocket launch. There are many resources available for further learning, including books, online courses, and simple experiments you can perform at home. Thank you for joining us on this enlightening journey through the world of physics, where we explored the profound contributions of Sir Isaac Newton and his revolutionary laws of motion. From the law of inertia to the relationship between force, mass, and acceleration, and the principle of action and reaction, we've seen how these laws shape our understanding of the physical world. Newton's insights have not only stood the test of time, but have also laid the foundation for countless scientific and technological advancements. Whether it's in engineering, aerospace, or everyday life, the principles of motion are all around us, influencing everything from the design of a car to the launch of a spacecraft. As we conclude our exploration, we encourage you to keep seeking knowledge and to observe these laws in action in your daily life. The next time you see a rocket launch or feel the push of acceleration in a car, remember the fundamental principles that make these experiences possible. For those eager to delve deeper, there are many resources available for further learning. From books and online courses to simple experiments you can perform at home, the world of physics is rich and fascinating. Thank you once again for your interest and engagement. We hope this guide has sparked your curiosity and inspired you to explore the wonders of physics. Remember, the journey of discovery is endless, and every step brings us closer to understanding the universe we inhabit. Until next time, keep asking questions, keep exploring, and keep pushing the boundaries of what we know. The universe is waiting for you to uncover its secrets. Thank you for watching. If you're hungry for more knowledge, hit that like button and don't forget to subscribe. Your support is incredibly valuable to us.